Hello, in this video I wanted to finish section 1.2 from last time when we met on Friday, and we started it, we were recapping section 1.1, the friend versus foe study, and so we went back through and talked about what is the null hypothesis, what's the alternative hypothesis, and rewrote them using symbols. If you recall in the 1.1 handout and when we watched the video in class, the babies choosing the friendly toy or the unfriendly toy, can they select? Can babies really tell between friendly behavior and unfriendly behavior? So the null hypothesis was that babies select the friendly toy by random chance. So they're just guessing. And the symbol for that is pi equals zero point 0.5. Pi is the long run proportion of success. So in this case, pi is the long run proportion that all babies under 1 year old choose the friendly toy. Since the null hypothesis we're saying that they're choosing by chance, then the long run proportion pi of them choosing the friendly toy is 1 out of 2, so zero point 0.5. And the alternative hypothesis is usually the theory. So babies prefer the friendly toy. And we said since babies have a preference, we expect the likelihood of choosing the friend toy to be larger than 1 out of 2, larger than half the time. So pi is greater than zero point 0.5 there. And we went on looking at the dot plot. And in this one, it said assume 1,000 repetitions. We want to find the approximate p-value. And the approximate p-value is the probability of obtaining a result as extreme as the one observed, assuming that the chance model is true. So this is assuming the null hypothesis is true. Now recall our extreme value, the observed value, was the 14 out of 16. So how many chose 14 out of 16? And we have the counter here. 14, only 1, 15, 0, and 16, 0. And this is out of 1,000 repetitions. Therefore, we have to get 14 or more is 1 out of 1,000. So the approximate p-value is 0.001. So how do we interpret this p-value? What is this the probability of? So if the null hypothesis is true, meaning if babies choose the friendly toy by chance, then there is a 0.1% probability that 14 out of 16 babies randomly choose the friendly toy. The 0.1% just comes from our p-value 0.001 and converting that to a percent. So remember, to convert a decimal to a percent, you move the decimal point twice to the right. So it becomes 0.1%. What conclusions can we draw from this p-value? Since the p-value is 0.001, there is extremely strong evidence against the null, so we support the alternative. Now this extremely strong comes from back in section 1.1, so I'm going to draw your attention to that. One of the very last pages of 1.1, it's page 6 out of 7. It had this box where we first defined the p-value, and it gave us the how to determine what our p-value means in terms of a conclusion. So this is where I am looking. So a p-value of 0.001 or less is generally considered to be extremely strong evidence against the null hypothesis, so against the chance model. So this box right here in section 1.1 will be extremely important when you're making conclusions. So going back to the 1.2 handout, that's where that's coming from. This is equal to 0.001, and that box said anything that is less than or equal to means we have extremely strong evidence against the null. So in the context of the study, that means there is extremely strong evidence to support the theory that babies prefer the nice toy. So they are not doing it by hand, by choice, by random guessing. And so here I made a note for significance levels. Look at page 6 of section 1.1. So that was that page that I just showed you over here. So depending on the approximate p-value, you can make a conclusion. And our definition here, what it does it mean to be statistically significant? If the observed results provide strong evidence that the data did not arise by random chance alone, that's what we consider to be statistically significant. So strong, that means we are wanting our p-values to be around 0.5, 0.01, 0.001. Notice that 0.1 is just some evidence. This is fairly strong, so as long as we have the word strong in there, that is acceptable. So 0.05, 0.01, 0.001 are acceptable p-values, and anything smaller than that. In this example, do people really prefer bottled water to ordinary tap water? So I wanted you to go through and do the same thing as we did for the friendly toy versus the unfriendly toy, and read the study and observe. Jot down what are the observational units, what is the variable. So here 27 people at the festival, type of water, and it is categorical binary because they pick tap or bottle. So there are only two choices. Even though there are 4 cups, we're really doing tap or bottled water, so still binary. A parameter for this study, parameter will be the population proportion, so pi, the long run proportion that people select tap water. Remember, pi refers to the entire population. And we don't know the entire population, but we can, the number, but we can infer based on the sample. Writing at the null and alternative hypothesis, so in words and in symbols. So in words, people select the cup with tap water by random chance. Kind of like with the baby study, they're guessing. It's just at random. They can't really tell, so they just guess on what they think is tap water. So that's the chance model. And the probability of that is 0.25 since there are 4 cups and only one contains the tap water. The alternative hypothesis is the theory. So what do researchers want to know? If you go back to the study, usually will tell you in here. And here it says researchers investigated whether tap water was chosen significantly less often than by random chance. So that is our alternative hypothesis. That's what researchers investigated. And so people select tap water significantly less often. In symbols, that's where the less than comes from. Since we want to see if people choose it significantly less often, that means the proportion of people who select it is going to be less than a quarter of the time. Our first statistic is the data. So 3 out of the 27 people chose tap water. The sample statistic in using the appropriate symbol is p hat. P hat is the symbol for the sample proportion, which is 0.11. And now you're going to do the simulation again, just as we did in class for the baby study. So here, explain why we cannot use a coin toss. Well, a coin toss only models 2 options, whereas we need 4. So what could we use instead? So here I want you to do the simulation handout, which can be found on your modules. So going to 1.2 is this one, the simulation handout.